One factoring method is greatest common factor. It could have two or more terms in its expanded form. For instance, for number 1, there's 2 terms, and if I want to convert this to factored form, I'm going to find the greatest common factor of both of those terms and pull that to the outside of parentheses. So the biggest number that divides 15 and 20 is 5, and then they both share x squared. So in terms of pulling out the exponent, I would look at the smallest number here. So between 3 and 2, the smallest was 2. So what would be left in the parentheses? So again, this is the GCF. What's left inside? Well, you're saying 5x squared times what gets me back to 15x to the third. So that would be 5x squared times 3x. Minus sign is in between the terms, so we're going to put a minus sign next. And then 5x squared times what gets me 20x squared. That would just be 4. So this is completely factored, and I know I picked the greatest common factor because there's no number that still divides the 3 and the 4 on the inside. For number 2 and number 3, you'll notice that there's 4 terms, and we're going to factor this by grouping and finding the greatest common factor of each group. So the first 2 terms make the first group, and then the last 2 terms make the second group. So if I factor each of these pairs by greatest common factor, what the x to the third and the negative 2x squared share is x squared. What's left inside? Well, x squared times x gets me back to x to the third. Bring down the minus sign. X squared times 2 gets me back to 2x squared. The plus sign that separates the terms, the groups, goes straight down. And then the second pair, biggest number that divides 5 and 10 would be 5. And they don't share any variables, so it's just a 5 on the outside. So 5x times x gets me back to 5x, and then minus 5x times 2 gets me back to 10. Something you'll notice with grouping, these parentheses should always match. So my final 2 factors, whenever you do grouping, you have 2 factors. One of the factors is the matching, the x minus 2. And if you shade out the x minus 2 as if you factored it to the front, because they both share x minus 2, what's left is your x squared plus 5. So that becomes your second factor, x squared plus 5. And again, you could write it as x minus 2 times x squared plus 5, or multiplication, the order doesn't matter, so you could write it as x squared plus 5 times x minus 2. So both of those work. So for number 3, same process, 4 terms, so I'm going to underline the first 2 and then the last 2, and factor each of these by finding the greatest common factor. So for the first pair, biggest number that divides 15 and 10 is 5. Looking at the variables, the first term has an a and a b, and the second term has a c and a b, so they both share this b in common. So I could pull that to the front. So 5b times what gets me back to 15ab? That would be 3a, plus 5b times what gets me back to 10cb? That would be 2c. Bring down the minus sign that separates the 2 groups. Next pair, biggest number that divides 6 and 4 is 2. And looking at what variables they share, I notice they both have a d, so we're pulling out a d. So 2d times what gets me back to 6ad, that would be 3a. And then I know that the parentheses has to match, so if this is a 3a plus 2c, then this has to be a 3a plus 2c. So I'm just going to fill that in and double check by distributing. So we've already checked this one because we said negative 2d times 3a is negative 6ad. And then let's check the second pair. Negative 2d times 2c is negative 4cd. So my final factored form here would be the following. The matching parentheses, 3a plus 2c. And again, if I shade those out, because we factored that to the front, what's left is 5b minus 2d. So 5b minus 2d.